Hello, listeners. Welcome to another episode of The Circuit. I am Ben Baharin.
Greetings, Internet. I'm Jay Goldberg.
So we just had the show of all shows. Jensen just had his Taylor Swift moment in the SAP Center, which was, I don't know, perhaps the most chaos I've ever seen for a semiconductor keynote. There was people violently running to seats, wanting to knock each other down, very much like an Apple keynote used to be. But this is semiconductors. It's not, the largest consumer electronics company in the world. And this whole sort of show, other people called it the Woodstock of semiconductors, whatever. The bottom line is this whole thing highlighted how central Nvidia is as the kingpin for this AI story, really the AI semiconductor story. Lots of interesting announcements that we'll get into. Lots of technology was shared. Jensen did some good job of staying focused and then also rambling, which I think we can appreciate. He does the sort of, here's my point, and then I'm going to go linger and say some things that I'm going to try to connect some dots and maybe not get there, which I know he knows. But let's sort of dive into a couple key takeaways. I'll let you start, and then I have two fundamental differences of framing that I took away from him that I think help us from a contextual standpoint. So I'll land on those after you sort of go top level takeaways.
So for context, I have not been to the show yet. I didn't go to the keynote. I listened to it online streaming. But then I also listened to his keynote, I listened to the investor Q&A, and then I listened to the industry analyst Q&A, which is 3 hours of Jensen talking. And one, that's mentally exhausting for me, for anybody. But two, it was really interesting to see his arc over that sort of 24-hour period, where by the end he was clearly tired and worn out and just got a little looser with his answers, which is useful.
Yep.
But I want to say, one of the things that was really interesting to me about it was he went on stage for his keynote in the SAP arena. It was 15,000 people. I mean, it's a huge, rock star level status for him. And it clearly, took him back. He mentioned in one of the later briefings, how tight his stomach was, how nervous he was on stage. And I thought that was kind of touching. I've never heard a CEO humanize himself in quite such a way to show that vulnerability. He was weak, he was scared. That was full credit to him. He's had this 25-year journey into Nvidia, and now he's a rock star of technology, and that's kind of cool. It's kind of cool to see for somebody. I think from the company perspective, I think this just cements my perception that Nvidia is now the dominant force in the data center.
Yep.
And that's going to go on for a long time, right? And if you're pressed for time, that's that's it. You can go. You can click off now, because that's what came out of this. They have so much going on every front, and they're so far ahead in so many important ways. They're going to keep doing well, and we can dig into all the different things that they have going on now, because there's a lot.
Yeah. Yeah, I think technologically, this was an interesting sort of step forward in a couple of ways, right? I think one thing that I don't know if this got glossed over, but I didn't see it get talked about a lot, and I do know from the QAs that you just mentioned, including ours, the industry analyst one, I think he tried to really seal this point, and I'm not sure everybody kind of grasped it, right? When he said that this new Blackwell architecture was two monolithic cores stitched together, I think the vast majority of people thought they were making chiplets. And he actually went out of his way to say it's not a chiplet. These are two monolithic cores stitched together. And then he used this phrase intentionally. They had to invent a new SerDes that could handle the bandwidth requirements of stitching those two chips together. Now, that is, on paper, very similar to how Apple stitched the Ultra together by taking a number of M cores, using the silicon interposer as a way to limit latency so that those two cores function as one. And so he again went out of his way to say it's not that it sees two cores, it sees one core, right? And this is an architectural change, but it's also a new way, not chiplets, to design these bigger packages, right, by stitching designs together. So I thought there was a lot of important context that went into that, because like I said, he tried to get people to not think they were making chiplets. They were still making a core monolithic architecture. They're stitching them together so it functions as one chip. Obviously that's useful, but at the end of the day, that is a very, very complex process that a lot of innovation had to go into that I'm not really sure he felt that they got the credit for. But there was a lot of technology right behind that I think was super, super useful. That again sets the stage for all of these pieces that they're doing, from the Grace CPU, all the way down to NVLink as back silicon, and how all these things again work together as one system. But architecturally, there was a lot of really good kind of juicy techno nuggets in Blackwell itself, and then again how they're using Blackwell to function as one functioning very, very big core without yet going to the chiplet era, at which I do think they will at some point, but they're not there yet. They're taking this approach to design right now.
It's a fair point. Like Blackwell itself, the chip is super interesting. I mean, it's so big and so powerful. It's a massive. I mean, do you see that? It's like it's like this big. It's like baseball sized chip.
Yep.
For me, what was really interesting was the fact that you had this, like you said, really architecturally differentiated, innovative new chip, but then they sort of replicated that level of innovation all the way up the stack.
Yeah.
Right. It's in a funky looking board. Like the chips are diagonal. I've never seen that before. It's kind of crazy. And so the server board is interesting. The way they've integrated them into racks and their networking stuff, lots of things happening there, and then all kinds of software pieces to tie it all together. I mean, this is a company that's firing on all cylinders. It's executing really, really well across everything.
Yep. And one other really important piece of sort of framing that I think hit for me that I didn't quite grasp coming into this GTC is really the degree that when Jensen talks about accelerated computing, he's trying to make it blatantly obvious, and I think the industry wants to still lump on pre-AI taxonomy and just say, you make GPUs, and that's kind of it, and you make some bits that make those GPUs faster. And if you recall the conversation we had last week with Austin, I pointed out that he's always still said that a GPU is general purpose, and I do think he believes that. I think when he says, and this is kind of the framing that he said, right? I think when he says that we make products for accelerated computing, he's talking about that entire rack that you just mentioned. And he went out of his way to say this exact phrase in the investor QA and the analyst QA. He said, we sell data centers. We just sell them in different parts. And his point was like, we can sell a complete data center, a complete rack to you. It's end to end, everything you need for AI right there. Or we could just sell you a couple GPUs and you could use your CPU. Or we could sell you NVLink and a GPU. And so his point was that they're very, very full stack. They're robust. And what stood out to me within this is subtly under the radar, and I think investors are starting to get this and others are, Nvidia is, and Jensen is kind of leading this overarching way to think about their company. And he's used this as when he says, we're not a silicon company, we're a platform company. But I think that gets moved now to all these bits of pieces that they're making, that Nvidia is a very strong and increasingly strong sum of the parts story. And I know that I use that phrase because investors use this phrase a lot, like we like the sum of the parts story, but it's because they're recognizing that this company is not a one-trick pony with one product. They're saying there's a lot of things that go together. They've got multiple revenue streams, and because of that, there's this big picture. It's a sum of those whole parts. And I think this GTC was kind of the first time, not blatantly as eloquent as sort of I just said that, but I think people are waking up to like, wow, like you build a whole lot. Like let's deeply appreciate your full stack. Whether or not everybody's going to go full stack with you, let's deeply appreciate everything that you've done, because there is a lot of great innovation there, from NVLink to the build to the GPUs to the heatsink to the cooling, obviously the software, yada yada. So I just think that some of the parts story is the nugget that I walked away with that is now being appreciated, and I think that's where he's been trying to get everybody to. Just it's been a really windy road to get there.
So I agree. with the big picture, absolutely. Let's unpack that a little bit. One of the things that really stood out for me was in the middle, at a very prominent moment in the investor Q&A session, he said, "No semiconductor company should be worth $1 trillion." like, like everybody's like, "What?" like,
Go Jensen.
right? Like this is all your shareholders here, and you said that you're not worth $1 trillion. And then he very quickly followed up and said, "No semiconductor company should be worth $1 trillion. We're not a semiconductor company."
Right.
That's like his way of saying what you just said, right? We do all these other things. We're a platform company. We buy and we sell data centers, and that's great. One of the things that's I think very different about Jensen is from other semi CEOs is that he likes to talk about the big picture, the vision, the long term science fiction bordering stuff, right? Most CEOs, semiconductor CEOs, come from engineering backgrounds and tend to, like to talk about the technical stuff, the specifics, the speeds and the feeds and all that. And like for them to learn how to talk in big vision stuff, they can do it. Like Pat does a pretty good job of it. Lisa does a pretty good job of it.
Right.
But it's not like you get the sense that like this is stuff he actually thinks about and talks about in his free time. Like it's clearly something it comes natural to him.
Right.
What makes him really dangerous though is if you ask him a technical question, he can get as much into the weeds as anybody. Like I'm pretty sure he can stand his own with any of his designers and possibly all of his computer scientists too. Like he's
totally
like the fact that he has both sides of that makes him formidable.
Yep.
In terms of like what is Nvidia, I think you go back to the roots of the company. They learned early on that it wasn't just enough to sell the chip; they had to actually sell the graphics card. And I think that's something that's sort of built into their DNA now. Is like you can't just sell a part and hope that the ecosystem does what you want with it. You gotta put more to it.
Right.
And they've just extended that from building a graphics card to like building a whole server rack or data center.
Yep.
So I think that's it's important. It's like that really does make them stand out.
Yeah.
What is it's interesting though because there's a layer of criticism that starting to attract now. I see this narrative appearing where people say, "Oh, customers are worried about getting locked into Nvidia. They don't want to take the whole solution from Nvidia." And I hear that often. Right, I was talking to like people keep talking about walled gardens. I keep hearing that phrase a lot, and I think what was interesting about that is, yes, I see that risk that Nvidia wants to sell you this whole stack, NVLink chips, servers, everything, but he went out of his way repeatedly over all 3 hours I heard him to say, "But if you don't want that, you can just buy the parts."
Yeah,
and I think that's like really it's counterintuitive. Like that's not what the strategy textbooks would tell you to do. Is your company, you're optimizing for your results. You want to sell the whole. You want the walled garden if you can, and they could credibly create this very, very formidable data center walled garden if they wanted to. I don't think they're heading that way. They're gonna push their own stuff. They're gonna promote their own stuff. They're gonna favor customers who want to buy more.
Right.
But at the same time, they're not going to pay a strategy tax and just get locked into selling the whole thing. You want the GPUs? Fine. We'll say, go build your own board. Have Supermicro or somebody build it for you.
Yeah. No, and I think that's a good point. But I also think there's the context to this, which is you're absolutely right. Some big formidable customers, and let's just call these the cloud hyperscalers. Yes, they don't want to get locked into that, and they want to control their own destiny. But there's plenty of customers out there, whether again it's the people that he talks about, right? Sovereign AI data factories, who for them the ROI is just simple enough because they're actually just trying to provide a service or solve a problem, that it's just easier, right, to go with NVIDIA. And in fact, in many ways, the same argument that you said, which I've heard too, is kind of like the thing that everybody always used against Apple. It's like, oh, nobody wants the walled gardens. Well, the walled garden's really easy. It's simple to use. And more often than not, it's going to meet 99% of your needs, and you're just going to be happier and better off because of it. And so I think there's a bunch of customers for that. In fact, if you recall, right, in the cloud Q&A, in the analyst Q&A, he said, look, we sell a full server rack solution for $4,500 a year, and we can sell those to name your number of people that want to buy them. It's a full turnkey solution, AI, basically factory right there. And so for a lot of people, that's going to make a ton of sense because
Yes.
they don't want to piecemeal these things together. So I think that part of their business is underappreciated, just how people just are going to want to go turnkey. But you're absolutely right. The fact that they do both means we give you customer optionality. But at the end of the day, I think they really do feel that this turnkey solution is going to satisfy a really, really big piece of the market.
I agree. I think this is something that's misunderstood by a fair chunk of the community, is the extent to which so many purchase decisions are going to be based off of, I don't want to say inertia, but like simplest path forward, right? And the top 5 to 10 hyperscalers will build their own systems and pick and choose, but nobody else will. Everyone else is going to take what Nvidia offers because it's that much simpler. And I think even some of the hyperscalers are just going to say, they're going to throw in the towel and say, this is like, right? You think about somebody like AWS or Azure, who absolutely can design their own systems and chips, and they definitely don't want all of the Nvidia stack. They will still have customers, right? All their enterprise customers who will want that, right? Who aren't going to want to have to contend with the differences and like, just give me the stuff with NVLink and let me run my model as efficiently as possible.
Right.
And I think that level of least path resistance is a big force in a lot of these purchase decisions that the sort of observer commentary undercounts, like how important that is. It's like I said last time, nobody's going to get fired at this point for buying Nvidia.
Right. So, but the part that this leads into, which is interesting, is a lot of the comments that were made around inference, because we've talked about this. We talked about this relative to their earnings, where they're trying to make more of a call to inference, and he articulated this in a way. And just going back to your point about kind of how Jensen sees things, one of the things that I have always appreciated in my time with talking with him is that he has a very good grasp of the problem itself, like the technical issue, right? What do we? And then he thinks about how to go solve these problems. And so the way he framed this for us around inference, I actually thought was super, super interesting, because one, he basically kind of came out and said, look, you got to remember, inference is perhaps a larger problem than training, because you are talking about being able to inference these models, multimodal models at scale, meaning that hundreds of thousands, tens of millions of people might be accessing and inferencing at one single time, right? And so that's scaling is a complex problem. But the part that was most interesting to me was kind of how he divided our history of information from the future. And he did that by basically saying, if you think about where we got to prior to generative AI or ChatGPT, everything was prescribed. So basically, you go for search for information on the internet, and it's information that's out there. It's already existed. It's already been written. It's already been published. These photos have already been made, right? It's existed. And his point was, we're transitioning into an area where all of that information going forward, or not all of it, but a good chunk of it, will be generative. Stuff that didn't exist before. Images that didn't exist before. Content that didn't exist before. Stories that didn't exist before. Generative movies and art that didn't exist before. And when you unpack the complexity of that problem, right, that we're moving to a completely different approach to how information is consumed and generated when it comes to internet services, our devices itself, the content that we make, that's a super interesting way to look at inference as a fairly complex problem, and really something that requires just a tremendous amount of compute to manage, to sort through, to interact with when this is being created. What we're asking for is brand new. It didn't exist before. And so I thought that was, I don't know where it goes. Again, everybody can talk about the challenge that Nvidia is going to face from a competitive standpoint from inference. But the reality is, I got a better appreciation of that problem, moving from prescripted information and data to generative information and data, just to understand how big of a problem this is, and probably why we've got a decent runway of innovation ahead of us, because we're not even really moving to an truly big, gigantic inference-based world yet. over the arc of the next, however many years, that compute will still be constrained because that's a really, really complex problem. So I thought that framing was helpful as we start to think about what does that mean, right, in terms of inference, a new way to consume and create information, and why that requires still tremendous amount of compute that we still don't have.
So I took his comments about inference a little bit differently, and not just because I'm apparently the house curmudgeon, but I this is the one place where I sensed a little bit of a vulnerability in the company's model, and vulnerability is a strong word, but because somebody asked him about NVLink, or we were talking about inference in the context of inference. Right. Why is your inference so much better? What makes Nvidia's inference so much more powerful? And he immediately said NVLink. And then he talked for a minute, and he said, "Oh yeah, also our tensor cores."
Right.
But clearly, like the thing top of mind was NVLink. And for those of you who aren't familiar with it, NVLink is essentially a networking layer, not data center to data center, but sort of chip to chip, server to server, right? And NVLink is very important. It's very powerful. It's a very clever piece of technology, but it's not for everybody. Right? It's not for everybody. Google, Amazon have architectural reasons that will limit their the appeal of NVLink to them pretty significantly. They can't really use it in their current stack. Amazon will find a way, but so there are lots of companies who NVLink doesn't necessarily work for, and it's expensive. It's it's an expensive layer. It is one of those options. Like you can buy the whole system composable. I think NVLink is the one place where a lot of customers are going to push back on buying it. They'll buy the big expensive GPU, the $30,000 GPU, but they don't want the NVLink.
Right.
Which tells me that there is room for others to get into inference. Right. If his answer had been why is Nvidia's inference so much better, and he had said, "Oh, we have this layer of things. We have software, we have NVLink, we have tensor cores, and multiple things." That's hard for anyone else to overcome. But if the advantage is just at the networking layer, which not everyone wants, right, that tells me that there's room for somebody else to get into inference, and that's the ball game, right? That means there is a ball game. That means that AMD and some of these others can actually start to chip away and gain some share in inference. Now, don't get me wrong. There's still a million reasons why most customers are going to stick with NVLink and with Nvidia, but it does at least open the door enough for somebody else to gain a little bit of share. And mostly, I'm thinking of AMD here. So it's not all perfect, but it was his comments on inference were said a lot. Now, I agree with your broader point that like compute is changing, but I think that's been my thesis for a long time now is AI isn't so much about like the really futuristic stuff. It's all the sort of smaller changes, the change in the nature of compute from deterministic to probabilistic computing.
Right.
That's really important.
Right.
And doing it on GPU is a much more. It doesn't work if you have to do it all on CPU. If you can do it a lot of this on GPU, it becomes economically viable.
Yep. Yeah, I definitely think that's a fair point. I mean, if there was a lot of questions that I wanted to be able to ask him, but one thing I would still like articulated is just prove to me that the GPU architectural is actually well positioned for inference, because it is for training and heavy visual compute. That's undisputed. But I don't think anyone has eloquently made the case that the GPU is the best place for inference yet. In fact, you would argue, right, that Intel, AMD, Grok, and others, right, are arguing that that's not the best architecture for inference. So I agree with you. I don't think he's framed the solution that NVIDIA has to that problem. But understanding the complexity of this problem, I think he's trying to say it still just requires a whole lot more compute than we have, and that's what GPUs are good for because they're parallel. You can just throw a bunch of workloads at them. But I agree with your point. I would love that to be articulated. I don't think it will anytime soon, but he definitely needs to land the why this architecture for this big inference problem that I just described, and I don't think that story's there yet for sure. Okay, so let's go.
Good for the world.
Agreed. I mean, that's the thing, right? We don't need to be dealing with a silicon monopoly as much as I think he wants to be. Not sort of on purpose, but yeah. A market one monopoly. So all right, let's talk about a couple other things. So there was a few things that flew under the radar. Um, but let's talk a little bit about some of the robotics. Again, I get it. I get it. They've been talking about robotics forever, and then there was some very interesting comments that he wanted to share more of a software defined 6G story, but had to take that out of his keynote. Um, but interesting beliefs, right? About whether anyway. So let's talk about those two things, right? Sort of these perhaps longer off. Where else are they going? That's not just data center and AI. What was some of the talks from robotics, and then kind of this? You're the network. You're the 5G 6G guy. Software defined 6G and Nvidia. What does that mean?
Okay, so let me do robotics first, and I'll get to 6G. Robotics, the thing that really caught my attention was he said he thinks that robotics, like human-shaped moving machines, robotics are going to have their Chat GPT moment this year or the next year. And given that Nvidia knows what everybody's working on, I paid attention to that because has he seen some demo that we're going to see in 6 months? That's really incredible. I don't know. I would love that seems really cool. But maybe I read too much science fiction.
So okay. So let's unpack that for a second. My assumption is that would mean that the robot is able to perform an unprescripted behavior that it observed or learned that was not prescribed before, like a task for it to do, right? Like robots,
Yes.
a robot mows or vacuums my house theoretically, but it has been pre-programmed to do so. So
Right.
something means that it's going to pick up a new behavior that it couldn't do before. So that's what we mean, right? We're unpacking that as a ChatGPT moment of robotics doing something they were not
Right.
prescribed to do,
Right.
which also sounds
Robot
weird
dance.
and scary.
Robot. Like it's going to be robot dance. Robot, write me a sonnet. Well, they could already do that. Robot, do some movable thing.
Right,
Waltz for me.
right.
That I think is that's what I'm. You know,
Okay.
he's got me waiting for now.
All right. So that'll be interesting, also scary. What about the 6G stuff?
So usually when anybody talks about 6G, I kind of tune out because
Yeah.
it's not coming anytime soon. But he made this really interesting case. He said, "What's 6G going to be? It's going to need a lot of massive MIMO for beamforming." True. Then he said, "What is beamforming? It's just ray tracing."
Oh
And
my
I was like,
gosh.
"Oh," I was like, you know what? He's right. He's right.
Oh man.
It's just a giant ray tracing problem. He's going to turn all of our cellular networks into video games.
This, though, again, is another example of he understands the problem and then goes, I got an architecture that can solve that problem.
Yeah, there was definitely a heavy element of that when he was talking about 6G, but at the same time, he's not wrong. Like his problem is that what he's talking about is the physical layer, the radio waves themselves, and I'm perfectly willing to believe that they have a really really compelling solution for base station architecture that does really incredible things at the physical layer. Getting that into the higher layer stuff is much more challenging. Now I know that they're working with Ericsson on something, and so when I say there's other stuff they have to do to get into the network, working with Ericsson is that's one way to do it, and so I don't totally discount that. I think it's an interesting idea. I think it's going to push everybody. It's certainly more interesting than 90% of the AI demos I saw at Mobile World Congress.
Yeah.
It's a compelling idea at a show that was lacking in compelling ideas.
Right. And one would think that anybody deploying next generation network topology is going to want to start to include, and by the time 6G, moves to mainstream, some element of intelligence that's helping it smartly navigate connection loads, diversify and balance across customers. That's to some degree, I mean, AI-ish. So yes, lots of compute. It's going to need to come to that. I think that's kind of his point. But the idea of software defined, right, networking, radio networking has been talked about, just not really commercialized at any kind of scale.
Yeah, I mean, I wrote about this, oh my God, like 10 years ago, which is if you start to look at, especially as we get to smaller cells, you need to have some very low level network game theory operations going around to contend with. If you have, if you have 1,000 small cells and a few blocks, you need them to be able to deal with each other, and like it has to be done at super super low latency, which means it has to be done on device. And so you connect all those dots, and what we really are talking about is putting some form of AI into self-organizing networks. That's a pretty significant change from where architectures are today
Yeah.
in mobile land, and it all of that stuff lends itself heavily to AI, which makes his point that Nvidia has a role to play in this pretty credible.
Yeah. Yeah. Agreed. Okay, so let's pontificate kind of a little bit about the road from here.
Wait, before we get there, two other
Yes.
things I thought were interesting from the show.
All right, let's go.
One was somebody asked him about exports, like export controls to China. And like he was pretty tired at that point, and so he kind of gave the sort of standard answer. But then he slipped up. He said, and we'll continue to ship degraded products to China. And then he stopped himself. And he said, not degraded, differently optimized chips or something. He used some
Optimized,
euphemism. But the fact that he admitted that like the H800, the part for China, is a
Right.
degraded version of the H100, which is what we always suspected.
Right.
And I think they just take the same die and they blow a couple fuses to, hamper it. They may even do it in software. I thought that was, like I said, by the end he was getting a little loose, and I'm sure his comms people were not thrilled with that, or his government relations people were not thrilled with that. But thank you for that little bit of honesty.
Yeah.
Another thing that is worth mentioning is still we got to understand it is this idea of NIMS,
Oh, NIMS. Yes.
which is
Yes.
NIMS, Nvidia. I don't even remember what it stands for, but it's basically
Inference
prepackaged
microservices. Nvidia
Inference
Inference
microservices.
microservices. Yep.
There we go. So it's prepackaged models. It's probably more than that. Prepackaged AI-based applications that they have in dozens and dozens of industries. And I think this bigger question, talking about sort of where they're going and systems company, there's this big question around software
Yeah.
with Nvidia. And a year ago when they launched Omniverse, or 2 years ago, whenever they launched Omniverse, it sounded a lot like they were planning to add software as a third or another revenue stream, another segment of the company. And since then, they've kind of backed off of that a little bit, but they're not giving a clear story. Like every time he's asked about it, he sort of dances around the question.
Yes.
If people have asked specifically, is how big is your revenue going to be from software? He pivots to product. He talks about NIMS and like other things. But it's still interesting. Like the NIMS and some of the comments he made about renting Blackwell $4,500 a year or whatever.
Right.
Like they're doing a lot here, and I'm it's something I think we need to keep watching because again, it's not clear where they're going. But software as a revenue stream for Nvidia is an important question, and I think the problem they have is if they go too far, they're going to step on the toes of their customers. So my guess is that they end up not monetizing software directly, but sort of at the fringes and using it to differentiate themselves. But I don't think they're headed towards big revenue streams from software. But it could be. And NIMS, these like sort of prepackaged libraries, are an interesting step in some direction.
Right. So yeah.
Last- Go ahead.
No, I was just saying this question was sort of directly asked in one of the QAs as well. You're right. He didn't want to come out and say, and in fact, that's why he specifically made the answer to the question I was telling you about, where he just basically said we sell this whole server $4,500 a year, and then he kind of made an interesting point that I hadn't quite thought about from his vernacular, which is like he said we provide the operating system for that. We provide the functional software side. But what that actually made me think about is that here again, right, to use this analogy, they're not maybe that distinctly different from Apple, which isn't necessarily monetizing the operating system or the software that they put on it via their own apps, but they are using it to differentiate their hardware, right? It's the platform play. It's the whole, those who are serious about hardware should also be serious about software situation, or vice versa. Was it those who are serious about software should also be serious about hardware, and take that approach so that maybe he doesn't need to monetize that. Maybe it's the services, so the subscription fees, the renting, the continued innovation to make those services or that box useful, and then that hardware, right, is the core bit, and everything in between CUDA, the operating system, right? That's really the differentiator.
Yeah, I think it's differentiation rather than revenue, and that's
Yeah,
important. But
agreed.
we'll see.
Again, which would be the same thing you'd say for Apple, right? Software is it's what makes
Yeah,
them stand out.
right,
They don't need to
right,
monetize their operating system, right?
right. So the last thing I thought that was important, and I know there's a lot of stuff here, we're getting up on time, but like I thought it was important. Somebody asked him about like what's the future, what are we going to see in AI software in the next few years? And again, he sees everything, and he's technical enough. He's deeply technical, so he understands what he's seeing. What he said was like, what's the future of AI software? What are we going to see coming out in the next few years? And he gave this whole long list, RNNs, CNNs, assisted learning, whatever. Go down. I'm blanking on all the names, but like it was a very long list. And what was critical about that is it's not just transformers; it's all these other things, right? I think that's important. I imagine that people deep into AI software kind of knew this. I mean, they're talking about it already. But there was a period a few months ago when everyone thought that like, okay, that's it. AI software is just going to be transformer based for the next few years, and that's clearly not the case. And I think that's a critical thing people have to understand is we're a long way from end state of AI software. We're going back to learn things. We're going to start using things that we sort of gave up on for a period during, or took a pause on during Transformers and ChatGPT's moment. We're going to turn back to those. Those are going to be still very important. And I think that's certainly important for companies like Grok and Etch, who we were talking about last time, who seem to be betting pretty heavily on Transformer. And I'm not like saying they're done. Quite the opposite. But it's still way too early to be talking about a chip market that's based on optimizing for a single model. That's just not the case. It's the opposite. We're going to start using lots of other models. We're still going to be using them for a long time, which means you're still going to want to use Nvidia and accelerators. The case for accelerators is still pretty challenging.
Yeah, I agree. And I thought that was an important sort of takeaway about how he tried to again go back to articulate the problem and say that's why I use the term multimodal, because he kind of said that a few times, is that you need support for everything, and the GPU does that. You could just throw whatever at it.
Right.
The software's there. It's very easy, etc. So, all right. So where do we go from here? One of the things that I wanted to ask in the public QA and didn't get a chance to was about this S curve related to computing and AI. He went out of his way to say he thinks we're in a 10-year cycle. We're 2 years into this 10-year cycle. I don't know if his unpacking of that means that we've got 8 years to go of crazy gains in computational capabilities, or if that's software or whatever. But the thing that I think everybody has a tendency to do is look at past computing S-curve cycles and see on those gains that at some point in time your year-over-year performance gains slow down. And once that happens, you're kind of like, well, I'm okay with the last product. I don't need the new one, right? The new one doesn't bring me enough ROI to make that investment. And so I would have loved to know, just in terms of this, from Jensen's capability or perspective, where he thinks we are in that computing S-curve. Because, if you go back and look, he was like, yeah, we've accelerated computing 1,000 times since this point in time. And that's great. But is it going to be another X amount in 4 or 5 years, or is this slowing down? And I do think there was some criticism, because I don't think they nailed the benchmark slides very well at all in this keynote. And people were like, oh, is it slower year over year gains? And so there was a question about how much performance gains are actually happening that was kind of unclear, right? Because people were starting to say, oh, you're actually slowing down now versus where Hopper was compared to, other products prior. But like I said, to me, some context there would at least say, yeah, we got a couple more years where every new product they release is such good value it makes sense. I don't know how the time is, but that's why I sort of frame it in terms of what's the S curve for performance gains here.
Yeah, I suspect very strongly that had he answered your question, he would have fallen back on the tropes he was using for the rest of his presentations, which was rather than talk about performance, he would have talked about this big giant market that's opening up. Right. The demand side of AI is exploding. That's his case. and I think I don't think he would have answered the question about performance gains, right? One of somebody on Twitter was saying, "Oh, people, Jensen says Moore's law is dead, but then he comes out and launches Blackwell, which has I forget how many transistors on it. But if you look at Blackwell versus Hopper, like it's a big size difference. I'm using my hands to demonstrate it on an audio platform, but it's like the current generation of the chip has more transistors than the last one, but it's also a lot bigger.
A lot bigger. Yep.
And so I don't. There are lots of reasons for that. I don't think the advances in performance are done. I don't. But this chip is what, a year older than H100, 2 years at most. Like, they're moving forward very quickly. I wouldn't be surprised if the R100 that comes next, we start to see increases in performance. I mean, it's still possible, I should say. Who knows what it's going to be? But like, there's still a lot of room for improvement there. But I think there is. I think you're onto something, which is certainly the performance gains are, like, for everybody in semis. It's getting harder and harder to develop.
Exactly, and it'll slow down at some point, right? But I think you're right. I think he went out of his way to talk about how they stitched these two monolithic cores together, and that they had to go invent a new SerDes so that there was no latency. And he even used this. He didn't answer, he answered a similar question about the future, but not specifically about performance, by saying, we believe we need a ton of compute to solve this problem, and if we have to go invent new things, we will. And that's why he said, like, we invented the SerDes and blah, blah, blah. And so I think his point is they've still got longevity. I don't disagree with that. I think I'm just kind of, for my own sake of expectation setting, trying to just gauge, like, how many more years of just sheer compute are we going to have this problem? But then I sort of, like, thought about this in terms of, I can't answer the performance gains, but if you think about it this way, it still takes 90 days to train a trillion parameter model, even with this new product. Now, it does it more efficiently, perhaps with less wattage. But think about where I think everybody in machine learning and AI wants to go, right? Their whole belief is that things someday will be trained in real time. So, like, we might have bazillion parameter models trained in real time, because that's when now you've got this really interested generative information, robots seeing the world, learning, being right, consuming all that information. We're nowhere near that. I mean, it takes 90 days, to train. It's 3 months to train a trillion parameter model, and we're talking about someday the holy grail is instantaneous training of gigantic amounts of data, including synthetic data, not even like prescribed data. So, to me, it just, again, paints the picture of how long we have, but I like thinking in terms of that way about, like, how much can we keep squeezing? At what point do those returns kind of go out? Only because I was trying to figure out, like, when does this train start to lose a head of steam? But that's nowhere in the foreseeable future.
You see, it's interesting because I came into the show with a little bit more of a not skeptical, but a little bit more downbeat expectations.
You're the household curmudgeon.
Well, fair enough. The thing I keep harping on is that, like, a lot of the AI gains we're seeing are for fairly small stuff. And so they started this keynote, and he started talking about, like, all these different things, like digital twins. I'm like, digital twins aren't new. Digital twins were created by AI. You can make them a little bit better, but maybe it's feasible now, but it's nothing new. Or cuLitho. Like, they spent a lot of time talking about cuLitho, which is their partnership with Synopsys.
Synopsys and TSMC.
And cuLitho, is technically just, it's awesome.
Yeah.
But if you think about what it's actually doing, it's like, it's like a 5 or 10% one-time performance boost that is incorporated into the design process. It's a fairly small gain of just one part of chip manufacture, one of the steps of chip manufacture. It's not like AI is going to design the whole chip, right? That's
sure.
That's where I came in from. But by the end of it, I was like, you know what? We're still in really, really early days. There's a lot of software advantages still to come, a lot of development still to come. And so, despite myself, I found myself more optimistic. I was like, oh yeah, I'm drinking the Kool-Aid. Accelerated computing. Not all the way there yet, but I do believe that there's more. We still got some good stuff coming.
That Nvidia green Kool-Aid is definitely tempting and tastes good. I'm with you. All right, well, good rundown. This was an exciting show. A lot of good stuff now to build momentum. So we'll we'll keep talking about it, I'm sure. But pivotal moment for the category, and good discussion on it. So thanks for listening, everybody, and we will talk to you again next time.
Thank you for listening, everybody. Tell your friends. Click like and subscribe, share, and all the rest. Have a good week.